Hello there. I'd like to welcome you to the Chapter 5 review session, also known, of course, as the Chapter 5 study guide. So it looks like I've drawn a nice, beautiful mountain with some rain on it and a beautiful lightning strike. So here we go. This is 14 or so questions, but it'll probably be more than that. So question number 1, here I have a nice rock. And how do you know if that rock has undergone any type of weathering? Or how do you know if the rock is weathered? And the answer is that it looks old, it looks beat up, worn down. A really good way to tell is if you crack the rock open. And you might have what's called a rind, just like a watermelon would have a rind, which indicates the work of the water and so forth and the acids attacking the surface of the rock. Now here at the bottom of the rock, or the base of the rock, we have little bits that have come from the rock. So could that possibly be proof that the rock is also undergoing erosion? And the answer is yes, because these are bits that have been removed from the weathered rock. So now what we're going to do is we're going to explore the different types of physical weathering. So you're going to name the type over here on the left side, and we're going to write a description over on the right. Now, I only made room for 2 of them out of the 4 of them, so we'll start with the first one. So the first one is frost wedging. How would you describe frost wedging? Well, what I've written here is that frost wedging basically is the description of breaking a rock apart by the work of ice. Water gets into cracks, it freezes, it expands up to 9%, so it breaks down the rock. Okay, the next one, a little bit more fancy perhaps, is exfoliation. Can you name the other term used for exfoliation? What's another name for exfoliation? And the answer is unloading. Okay, can you describe exfoliation? Well, exfoliation typically occurs in granite, and it's where it develops onion-like layers when that granitic pluton has come to the surface and undergone pressure release. All the pressure has been removed. Here's a third type. This is a rock that looks like it's got green worms growing in it, but this is actually some grass. So what is that grass doing to break the rock apart? Well, the broad category that this belongs to, this is a work of plants or animals, which is a physical weathering process that breaks the rock down. The fourth and final one of physical weathering, here we have a guy in the summertime here in Houston, and boy is it hot. So is the sidewalk that he's walking on, is it also getting hot? And in the wintertime, of course, it might get a little chilly around here, so the sidewalk and all sorts of other stuff is going to get cold. So when it heats up and gets cold all the time, that is known as thermal expansion in the summertime, thermal expansion. And in the wintertime, it's also called thermal contraction. But of course, thermal expansion and contraction can happen during the course of the day. It gets hot during the day and it gets cold at night, and so rocks basically break apart through the action of thermal means. So question number 3, there's some stuff falling out of the sky from a cloud, and people are these days call that some type of rain, which might burn your face. What is the likely pH of acid rain? What's the number? So if you guessed around 4 or 5, then you're pretty much right on target. Now we're going to explore the different types of chemical weathering, and we begin with the first one. This one is dissolution. So the question I have to pose here with doceri, what type of rock is susceptible to dissolution? And dissolution or dissolving by what type of chemical? So the answer is anything with a pink dot in your lab kits, anything that is limestone or marble or anything with calcite. And this is how caves are formed, of course. Number 2 starts with an O because the element in question also starts with an O. So this is oxidation, when rocks will chemically change through the work of oxygen. The third one is HY something, which involves water, and that is hydrolysis. So now with question number 5, I've drawn a nice big box which represents a huge boulder. And I'm going to break that boulder down into smaller chunks of boulders, maybe smaller cubes. So what have I actually done to break the big boulder into smaller boulders? Is that a chemical weathering process or a physical weathering process? And it is a physical weathering process because I'm physically breaking down that rock into smaller bits. But by doing so, does that actually increase the rate of chemical weathering as well? And the answer is yes, because you're increasing the surface area, more area for acid rain and so forth to attack. So now we're getting into the morbid part of docere here in Chapter 5 with a grave marker who has the last name of Parker. And this grave marker has the last name of Joe. So Parker and Joe. It looks like Parker's gravestone is made of an igneous rock because it's got the familiar pluses. And Joe is perhaps a metamorphic rock, probably the metamorphic rock that's made out of calcite. So here we have a granite over here on the left side, and of course marble is on the right side. So we're going to use this basic knowledge into the next 3 or 4 slides, and we're going to put them in different places. So before we go, the question that is posed, which one is susceptible to chemical weathering? And if you guessed marble, that is absolutely correct. So here we go to Arizona and also to West Virginia. So we have marble in both West Virginia and Arizona. So when you know this, which one is now susceptible to chemical weathering? Is it the one in Arizona or the one in West Virginia? And as we probably talked about in lecture, over here in the east it gets very humid and a lot of moisture. And over here in the west it's very dry. So the one in West Virginia in the east is going to be more susceptible to chemical weathering. So now we have a little bit different ball game. We have granite gravestone or a memorial marker or whatever in both Arizona and West Virginia. And now the question becomes, which one is more susceptible to physical weathering? And of course it's just the opposite of chemical weathering. It's the one out there in Arizona where it's real dry. And what I've written here is that physical weathering is dominant in Arizona and also other states of the West, not to mean that chemical weathering isn't there too. So now we're going to mix it up. We're going to put both gravestone types in both states. We're going to have granite and marble in Arizona and granite and marble in West Virginia. So now the question becomes, are all the rocks going to weather at the same rate? Now I have to elaborate on that because are they going to, the granite and marble, are they going to weather differently than the ones in Arizona? Are they going to weather differently than the ones in West Virginia? And the answer is yes, but both the granite and the marble are going to weather differently from each other in each state compared to the other ones. So when rocks weather at different rates, because one is maybe harder than the other, as in the case of this picture here, we have a sandstone on top and a shale which is weaker down below. Do you remember what that's called? The concept, when rocks weather at different rates. That is differential weathering. It starts with a D. I try to help you out there. And the rock here at the top, because it's so much larger and harder, it starts with a C when it forms this type of configuration. And that is a cap rock. So back to our USA map, we have physical weathering dominant over here in the west, and we have chemical weathering that's dominant in the east. So the question is, where are you likely to find lots of cap rocks? Where are you going to find lots of cap rocks? And over here in the west, you're going to find tons of places where you're going to find lots of beautiful landscapes. So really for trivia purposes, I decided to include this in here because I've traveled America. There's a fantastic national park among many national parks, not only in Utah but in the American West. But one in particular in Utah is called Bryce Canyon National Park, and it is famous for its hoodoos. So I would encourage you to get on the internet and type in hoodoos at Bryce Canyon National Park and see what you come up with. Here in northern Arizona, which is near the Grand Canyon, we have Monument Valley, Arizona. And Monument Valley is named because there's rocks out there that are huge, big, flat tables of resistant rock, which are called plateaus. Smaller resistant rock are called mesas, and little pinnacles like that are called buttes. So you may have seen that word butte in the Pixar movie Cars, when the little old lady slaps the bumper sticker on the tourists that come through town. So here's question number 8. Question number 8 is describing a rock outcrop that has kind of round or sphere-like rocks in it. So they may have begun their life pretty angular, but now they're round. So what type of weathering is that starts with an SP? And the answer is spheroidal weathering. And this likely or usually occurs in a granite. So now with question number 9, we're going to turn our attention to the skin of the earth. So every layer of the earth, or most places in the earth, of the continents at least, are covered with loose stuff, which is called soil, or the layman would call it dirt. So let's examine this dirt, and I'm actually going to skip ahead now and talk about the different layers of the dirt. And this is a pretty involved slide, which actually has a lot of visual aids on it. So we have different layers of the soil, and down below we have the bedrock. So we're now going to get into the layers of the soil profile. We're going to go through all the letters. So which layer is on top where the grass grows? Okay, that's the O horizon. Next under it is the A. Next, E. What comes after that? The B. Now, the C. Okay, now the E and the B have special names. So what is the special name for the E horizon? So that's the zone of leaching. And what about the one below that? The B horizon is called the zone of accumulation because heavy metals typically will leach out of the E and into the B. Now, of course, the layer C is called the zone of partly altered bedrock, which is loaded with kind of a rotten rock, which is called saprolite. So when you consider all this loose stuff that covers everything, what do you call that loose stuff again? The skin of the earth? So we call that soil or dirt. But now when you consider everything, the loose stuff and the bedrock which is below it, that is basically a chunk or a layer that starts with the letter R. And that is known as the regolith. Okay, question 6 plus 4. So this question says, what does in situ mean? What does in situ mean? And in situ is Latin for in place. So the follow-up question to that is, does in situ describe a residual or a transported soil? And the answer is residual soil. Question number 11. We've got 3 more questions to go, and that's it. So limestone is down below your soil horizon layers, which is made of clay. So what is the likely material that the soil itself is going to be made of if this is a residual soil? And the obvious answer is it's also going to be made of clay because it was derived from the limestone. Here is 11A. Now we've got to switch it up with metamorphic rocks below. And specifically we'll call it a metamorphic schist, which is loaded with mica, as I found at Auburn when I went to school there. So what is the soil likely to be loaded with? And yes, it is loaded with mica. So now we're going to get into all the different factors that can affect soil formation. So you're going to see this title about 5 or 6 times in different slides. So here we go. Here's a USA, and we have the dividing line between the east and the west. So that is basically describing the C word, which is climate, with water, of course, being the most influential factor of weathering and erosion of rock in order to make soil. So soil formation factor number 2, we have limestone down below, we've got a clay soil above. So since the clay was derived from the limestone is called the what to clay, and that is the parent material. So it really does matter what the parent is as far as what your soil is going to be and what you're going to get out. So soil formation factor number 3. So let's see what we got on this slide. Oh, we got something kind of weird. 1, 2, 3, 4, 5. That looks like a clock. So a clock is used to tell time. So time is another factor in soil formation. The more of it you have, and the more the rock sits around weathering and eroding, the more mature the soil horizon will be. So you have to decide to understand what that means. A mature soil horizon versus an immature. Okay, for soil formation factor number 4, we have different levels of maybe the edge of a plateau or a mesa. We have A, B, and C. So which one of the letters A, B, and C, which one will not have a soil on it? And that is B, because it's too steep. And that is another factor of soil formation, is slope. Which is likely to have a residual soil? Okay, A is likely to have a residual soil, but you might be asking, well, why wasn't it C? Well, junk that's falling down from the slope at B is probably filling in the valley in C, so C is likely to have a transported soil, but you have to check it. Okay, soil formation factor, this is number 5. So we've got a nice tree, or a feeble attempt at a tree, and we have some little critters called earthworms that are digging in the soil. So what contribution to soil formation is that? So that is the contribution of the work of plants or animals. So now we're going to get into something else. This is question number 13. What are some things that make up a good soil? Can you name one? Well, a good soil is going to have water in it, right? Okay, it's also going to have air. You're going to have some organic material that was contributed by your little earthworms in the previous slide. And another thing you're going to have in a good soil is some mineral material, some mineral matters. Kaolinite, orthoclase feldspar, quartz action, all the minerals that you know and love. So this may be it as far as my questions for this Chapter 5 review. Here we have a soil that's loaded with lots of vegetation. It's loaded with grass and a tree or two. And over here we have a barren soil with no vegetation. So which soil, the loaded with vegetation or not, is likely to have or more susceptible to erosion? And of course the one that doesn't have any vegetation, because the vegetation actually anchors the soil and keeps the soil from eroding away. So that does conclude the end of Chapter 5 review.